Okay, everybody. Operations on radicals. So this is our last part of chapter 1. It is the end of 4.1. We're going to be adding, subtracting, and multiplying our radicals. We just went over how to simplify them by making factor trees, and now we're going to figure out how to add, subtract, and multiply. So number 2 says perform the indicated operation, and we have 5 root 7 plus root 11 minus 8 root 7. Now, the first thing I want to kind of go back and look at is I want you to remember chapter 2 when we were doing things like this: x squared minus 3x plus 4x minus 9. And we had to simplify that, and we said, okay, well, we're going to do that by combining like terms. So we found the like terms. We said negative 3x plus 4x, we would add those together, was 1x. And then we would simply drop down our minus 9 and drop down our x squared, and that would be our polynomial written in standard form. Same thing, it just looks funny. So in letter A, 5 root 7 plus root 11 minus 8 root 7, we first have to identify the like terms. So this was negative 3x plus 4x. They both had an x. So over here, we have 5 root 7 minus 8 root 7. The other way I tend to say this is 5 of these things minus 8 of these things would give me negative 3 of those things. So when you're adding and subtracting with radicals, the radical does not change. It's just the coefficient in the front. Just like if you're adding and subtracting with your x's, negative 3x plus 4x is 1x. The x doesn't change. It's just the coefficient in the front. Then my root 11 is not a like term, so I would just bring him down, and this would be your final answer. Now, if you were to write this as root 11 minus 3 root 7, also acceptable. When we're dealing with radicals at the moment, there really isn't a standard form, so to speak. So it doesn't really matter which one you write in the front or which one you write in the back. Just make sure that this negative 3 still has a negative 3 on it, whether you write it first or second. Let's try again. Letter E, 10 root 5 plus root 20. Now, we just had a conversation about like terms, and I'm looking at 10 root 5 plus root 20 going, well, those aren't like terms, I can't add them together. But then I'm looking at root 20 going, but I wonder if that is simplified. So let's go to 20 and break it down. 10 times 2, circle the 2. 10 is 5 times 2, circle the 2, circle the 5. Now we can't use the 10 because that broke down further. And this is just a normal square root, so we're looking for groups of 2. So I'm going to pair the 2's together. One gets out, the other one doesn't make it. 5 doesn't have a buddy, so we're going to put him back inside. So the square root of 20 just simplifies into 2 root 5. Well, then I'm going to go back up and I'm going to say, well, this was 10 root 5. So now I have 10 root 5 plus 2 root 5. So again, 10 of those things plus 2 of those things makes 12 of those things, and that's your final answer. Again, the radical doesn't change, it's just the coefficient in the front. Letter B, 6 times the cube root of x plus 2 times the cube root of x. Well, like terms, I have 6 cube roots of x's. I have 2 cube roots of x's. So 6 of those things plus 2 of those things, they're already like terms, gives me 8 cube roots of x's. And we're done. We didn't even have to simplify.